All right. Welcome to part 2 of the Dactyl Manuform build stream. Today, we're going to keep going with building our left half of our keyboard here. We're going to start off today with doing some diodes here. So, going to be bending them first. So last time we talked about, I'm going to go down a little bit here. Last time we talked about a little bit about the keyboard matrix, and what we did in the last stream was we created the columns. So we connected these switches into columns, and what we need to do today is we're going to connect them horizontally as rows. So what we need to do in order to prevent any signals from getting crossed or registering incorrect key presses is we have to use a little electrical component called a diode. So I'm going to grab a little bag of these bad boys. There should be enough in here. If not, I've got another bag. So these are the diodes. I'm going to do my best to start putting some links into the video description so that you can see, maybe where to get some of these. We are going to need a diode for each switch on this board. So I think it comes out to like, I want to say like 62 or 64 for the Dactyl Manuform 5x6. So I'm just going to see what we got here. 5, 10, 15, 20, 25, 40, 45, 50, 60. Okay, so this should be plenty. So I'm just gonna cut this off, and that'll be about the right number. So this is another part of building the keyboard that takes a while. So these diodes, when you're looking at them, I'm going to try the microscope again. Let's see. So there we go. That actually worked. So if we're looking at the diode itself, basically this is a little electrical component that keeps the electricity from flowing backwards, or basically it allows the electricity to only flow through it in one direction. So when we're looking at the diodes, and this is no matter what brand or whatever, they will have a little black mark on one end, which kind of goes all the way around it. That side, it means that the electricity is going to be able to flow. It's only going to be able to go this way, okay? So it's not going to be able to flow back this way. So when we connect these, I'll take this one out. When we connect these, the end with the little black mark is going to be pointing kind of up and out, and the other end of this is going to get connected to our second pin of each switch. So basically we're going to end up having this side connected to the switch, and the other side going this way. And this other end of it is going to be connected basically to a rail, sometimes they'll call it, but basically just they're all going to be connected going horizontally. So you can see, like, if we're doing that, and we're kind of going to be making this like an L shape almost to connect these together, That's probably never going to be in focus. There we go. You know, we don't need all of this down here. It's kind of going to get in the way. We do want to leave this intact because that's going to form our bridge that's going to connect all of these diodes together. But we want to be able to connect this part easily to our pin on the switch. So, you know, when I was doing my first one of these, I was trying to hold, like, cut this off and then hold the thing with the tweezers, you know, and then solder with my other 4 hands, and that doesn't really work too well. So what we're gonna do is, first of all, we're gonna be connecting them. We're gonna be bending them a little bit differently, and then we're gonna solder them onto the switches, and then we'll do the soldering of the row. So what you can do if you're just doing one of these boards, or you know, you're not going to be doing like a dozen of them, is you can just take your pliers or something like that, and take that and just take the back of this and wrap it around like that. So what we're doing is just creating a little loop, and then that loop is what is going to, that loop is what is going to go around the pin on the switch, and that's going to make it a lot easier to solder because it's not going to fall off. So for example, that would maybe look something like, let's see. Turn on the light on this bad boy. There we go. Okay, so we can see the pin there. This loop is going to just go over that pin, just like that. And then we're gonna solder that on to the pin, okay? And you can see the copper's pretty close there, so we wanna be real careful that we don't accidentally bridge that to the copper columns, okay? So move this back. Okay. So basically, you know, when you're doing this, you want to sort of get all of your bending or whatever step you're on, you want to do all of that at once, because you can do it a little bit faster than, you know, bending one and then soldering one, bending one and then soldering another one. So there's a couple ways you can do this. There's nothing wrong with just doing it with your pliers and just wrapping it around like that. That is fine. However, if you're doing a bunch of these, it doesn't hurt to make yourself a little jig. So this is this is very ugly, but this is a jig that I actually made for wrapping wires to go to become the columns on the Dactyl Manuform. So each of these numbers goes to a different column. So you can see these shorter ones, you would wrap it, creating little loops in the wire, and then you can pull the wire off, and then you're going to just set it, for example, like 5 and 6. That's this and this. So those pieces of wire you would just set right down in there, and you'd be good to go. I still actually, even with this, I think as long as it works okay, I like the copper tape because that gets rid of this step altogether. So that's great. So let's see, what are we gonna do here? Let's wrap some diodes. Let's wrap some diodes. So what I'm going to do is set this right here. And I don't know if this is going to be good or not. Yeah, that'll focus. Okay. It's just very, very bright. Let's see. Maybe like this. So I'm just going to set the diode here, and I've got the black line, that end pointed up here because we want it pointed away from the switch pin. So this, I'm just gonna wrap this around and then push that over, and what I have is a diode that is ready to get soldered. So I'm just gonna go ahead and I'm throwing this each of these diodes into this little magnetic tray. Otherwise, they have a tendency to just fly all over the place. So, gonna do this a bunch. So, just want to say thanks to everybody who watched the first part of the stream. I really appreciate you. I had a couple of questions. I'm going to try to talk and do this at the same time. I had a couple of questions. One of them was about doing per key RGB on this board, which is possible, but it just takes a really long time because you're doing basically hand wiring an entirely additional set of components to each switch. So it's not impossible, but it is not something that I usually undertake, especially for a build like this. But I did create, we probably will touch on, and this will probably be at the very end of this series, but we'll probably touch on doing a little bit of RGB underglow. So that was super confusing to me when I started doing this. It was the difference between backlighting and underglow. So backlighting, even though it sounds like, oh, lighting that is coming from the back. Nope, it's actually the opposite. So think of it as you are backlighting each key. So, you know, if you have keys with translucent legends on them or whatever, you know, when you're doing RGB backlighting, that is going to be light that is coming up through the key, and that's the reason that a lot of the switches have a little hole in them, is for that LED to be able to be put through it, so the light will be able to come out and it won't be blocked by the body of the switch. So so that's backlighting, and then the underglow, so RGB underglow, is when you've got lights. Basically, think of it as like lights pointing down from the keyboard. So, you know, if you had a PCB, they would be on the bottom of the PCB, basically pointing down. And, you know, it's sort of like, I don't know, your little Fast and the Furious cars with the neon lights on the bottom, kind of lighting up underneath the board instead of having the lights point up at the typist. There we go. So that type of lighting is a little bit easier and simpler to do, and I actually just finished a build where I had done a case that was like a translucent green color, like weird kryptonite kind of deal, and I ended up only putting 3 LEDs per side, but instead of having them point down, I had them in the case, mounted to the bottom of the case, pointed up. So in effect, it actually was doing backlighting, but the way they were wired and the part of the firmware that we were using to control them is actually the underglow part of the firmware. And QMK is really interesting. We didn't really talk about that yet, but the firmware that we're going to be using for the Dactyl Manuform is called QMK. It is an open source project. I believe it's owned and was started by the OLKB people, the ortholinear keyboards, like the Plank and stuff. So it's very cool. It's a really cool project. There's a really good resources for learning it. I don't really have any programming experience, but I was able to, kind of find my way around it well enough to, actually do a couple of custom boards basically from scratch, like without adapting an existing layout. So if I can do it, you can definitely do it. So what we can do there is built into that QMK firmware. There's actually there are a bunch of RGB animation modes, which is really cool. So if you just think of like you want the light to chase around, like you have 6. In that case, I had 6 of these underglow RGB lights, and you want them to like chase each other around or whatever. As long as you have them wired in the right sequence, you can access all of those animation modes, which is very cool. And probably like those would take a very long time to program yourself, I feel like. So that's pretty neat. And the LEDs that we use, and I think I put this in one of the comments, but the LEDs that we use for that are, I believe they're called WS2812. And you can get them in a couple of different formats. I think they sell them as those strip lights, kind of like rubber strip lights. But what I have used actually is this. This is just a PCB that's cut. It's got the LEDs already soldered onto it, along with the, I think it's a resistor or whatever you usually need for LEDs. And you just crack these off. Like you just pop one of them off, and then on the back of it you have the little contacts where you can solder the 3 wires that are needed. So I think there's 5-volt in, there's a ground, and then basically a digital pin that is going to be connected to a data pin on your Pro Micro or whatever microcontroller you're using. And so obviously there's the power and the ground, and that middle contact allows you to tell each of the LEDs what you want them to do. And they're addressable, and that's true in QMK. They're addressable, so you could tell each of those LEDs what you want them to do, which is pretty sweet. So we also had there was another question about if we are going to cover the firmware, which is QMK. That's the firmware we're going to be using. And yes, we'll go into it a little bit. I am at least going to show you how to get the hex file that's needed to flash to the microcontroller. And there's a lot of good tutorials already out there about installing. There's a app called QMK Toolbox, which makes it a lot easier to do this firmware flashing, at least on the Pro Micros. On some of the other ones, I haven't had a lot of luck. Some boards where I've used the Teensy, I had to use another program, little app. I think it was just called like Teensy Uploader or something like that. But basically, as long as you can create the hex file, or you can get the hex file, basically all you need to do from there is just flash it to the microcontroller. So we will go over that a little bit. The nice thing about this build of the Dactyl Manuform is it took me a long time to figure out like oh, okay, what's, there's so many different tutorials and things out there. Like, it took a long time to figure out, like, oh, well, here's a tutorial about wiring, but Lord only knows which version of the firmware goes along with this wiring, because if you get one that was wired differently and the person made the firmware for that, it's not going to work with the way that we're wiring our keyboard matrix. So this one works with the what I would call basically the default setup in QMK, which is good, because then we don't have to go in and do a whole bunch of crazy stuff to get one that works. The other nice thing about that is that since it's something that's already in the repository, like it's been, there's been it's been pulled into the main, I don't even know, the GitHub basically. It's easy to get, and also what that means is that there's another app called QMK Configurator, which is a web app that seems like it's coming along pretty nicely. That does have, since this is in the GitHub repo, that QMK Configurator tool has the Dactyl Manuform with this default key map. So it makes it a little bit easier to create that hex file without having to install a bunch of crazy stuff on your computer. Because there's the QMK toolbox, but in addition to that, there's a bunch of other little components that, if they're not all set up just right, it seems not to want to work. So that is a nice tool. I'll put a link to that in the description as well if you want to kind of check it out before we get to that stage. That is fine. I'm doing all the diodes right now for both sides, but I think this is the last one. Got to make sure you don't end up flipping these and having the black end down here, because that will keep that switch from working. Loop this last one, push it down, over, and there we go. So I got a big pile of weird art sculptures. Okay, so I think we're done with this. We're going to put that away. Create an avalanche. Okay, and all right, so let's actually put these on our board. Oh, wait, I think I needed to do these too. Let's do a few more, why not? Okay, a couple more. This part is pretty repetitive, but it's not too bad. Even if you're just doing it with pliers, it's not really all that bad. It's just grab one, loop it, and throw it in your little magnet tray. There we go. Okay. There we go. Okay, and we're making this little 90-degree angle in the diode leg so that it's going to be easier to connect them together when we form those horizontal rails. Okay. Put this down. Okay, and also when we're doing our columns, and today when we're doing our rows, they're not actually connected to anything yet. That's a step we're going to be doing maybe in the next part. So you'll see the column is connected to itself, like the switches there are connected to themselves, but they're not connected to the microcontroller yet. So they don't really do anything until we do that. But that'll be a stuff that we do a little bit later. Okay, leave that over. Over. Keep flipping these upside down. It helps if you keep the thing you're pulling from, keep this oriented in the right direction so you don't accidentally pull one off and put it in the wrong spot. Over. Okay. And this is just this little shape here, and this was just a hunk of 3D printed stuff. This could be anything. This could be a piece of wood. This could be a piece of cardboard. This could be anything. All of this is just nothing. This is actually, if you look how tiny this is, this was a printed piece of a prototype that I'm working on, but I had scaled it incorrectly. So the only switch and stabilizer that would fit in here are maybe about 70 or 80% of the size of a real one. So if anyone has any cherry switches that have been bewitched and shrunken accidentally by a witch, please send them to me. We'll pay handsomely for them. Okay, one more. Okay, so going to turn on our soldering iron. I'm gonna put our microscope on for this wiggly mess. Turn on our soldering iron. I'm gonna be back in just 2 seconds. Okay, sorry about that. We've got our solder now. And okay, we're gonna get rid of that. We've got our can of goods, and you know, we're gonna start at the back basically, just so there's less in our way. When we're doing this, we're kind of trying to anticipate, you know, when we add something to this, is it going to make it harder to add more to it? So, you know, if we started down here, we'd be working over the stuff that we already put in there, and that would probably make our lives a little harder. So we're gonna start back here, which is at the top of the board. So there's a few ways to do this, but I will just show you what I usually do. So this you may have to bend or move around a little bit to make this fit here. Let me see. Let's see if I can show this a little better. Let's see. boy, it looks terrible up close. Interesting. Let's see. Okay, it's out of focus, but that's what we got. So I'm just gonna lay this on here. What I want is just for this loop to go over the pin on the switch. So that's like that, like we were looking at before. So it's just looped around that the free pin on the switch. We're not using the same one that we did for the columns. We're using the other pin on each switch. Okay. Okay. So I'm gonna keep going with this. I want to see like how close can we get and still have this focus. I think that'll be all right. So I'm gonna go through and just set one row of these onto the pins. Okay, doesn't really matter. You don't have to be perfect with, you know, where they're going. We're gonna kind of straighten them out in a second, and that's a lot easier to do after we've put a little solder on there. This one here. Okay, and you can kind of, you know, as you're doing this, not that we would ever make any mistakes, but you can kind of just double check when you're putting these on. Make sure that little black line is going the right way, and make sure we didn't do any of these incorrectly by mistake. Put that. Try to get through this whole row. Oops. Nope. There we go. Oh, this is a pretty fussy little part here. Where's my tweezers? Where's my good tweezers? I need to tweeze. Shit. Oh well, I don't know. Sometimes this helps to have these little guys here. Also, if you're finding this too difficult to set up a whole row of these at a time, you can do, you can do half of the row, solder them, and then those diodes are not going to be bouncing all over the case. So we've got our soldering iron heated up, and we've got our solder. We've got more beverages. Okay, so we'll do these 4 and then do the other 2. That'll make it a lot easier. So it's gonna go like this. The legs on these heat up really quickly because they're super thin. So it doesn't take a lot. I also had somebody mention in the comments for the last video that I had all this poisonous smoke going straight into my face, which is a very good point. Usually I have a little smoke eater thing, but it is so loud that you would not be able to hear anything I'm saying. So I'm just being very careful. I'm blowing the smoke away, and I have the room ventilated. So as long as you're not breathing it in or starting to concentrate too much of it into the room, you should be okay. But that is something that is a very good point, and you should be safe when you're doing this. Let's see. Oh, the other thing is, you should definitely some people kind of laugh at this, but you should definitely wear eye protection anytime you're soldering, because anytime, I don't know if you, like, if you've ever melted metal before, you know, it becomes a liquid, so you can have little drips and drops and stuff kind of spatter around, and every once in a while, like, you just hit it just right and it kind of pops a little bit, and that can send a little bead of really hot metal flying up into the air, and we don't want that to go in our eyeballs. So I wear glasses, so I'm good, but if I didn't, I would have some safety glasses on right now, because I need to be able to see things. Let's see. Put that last one on there. Boy, oh boy, that's fuzzy. Okay. There we go. Do that last one. Okay. Very nice. So we've got all those done. It looks very looks pretty messy, but that is okay at this stage. What I like to do actually is to go through the whole thing and just connect the bottom leg of each of these diodes to all the switches, and then go back through and start actually connecting them into rows. So we will just keep going with this. Okay, and you know, I don't know, just to kind of touch on the whole soldering thing, before I started getting into keyboards and building keyboards, which was, you know, I don't know, like less than 6 months ago, I had no idea how to solder. And I think, like most people, you know, the first thing I did was I bought the crappiest possible soldering iron. It was like, you know, $15 at the hardware store, which, you know, those are fine if you're doing like larger soldering stuff, but for this smaller kind of stuff, I seriously think that it is worth it to get something a little bit nicer, if you can afford it. If you're just doing one keyboard project, you can scrape by with the you know, $20 one or whatever from the hardware store, but you will have a much more difficult time doing that. So if you can drop, I think there's a few other ones that I'm kind of seeing around now. I think there's one like the TS80 and TS100, which are really super like compact ones, that have the controller built into the handle of the iron, which is cool. So those are neat. I'm sure those are good for this. But I am using the Hakko FX888D, and that's a pretty popular one among like hobbyist electronics people. I like it a lot, and it comes with a couple of tips. You can actually change the tip out on the iron, which is great, and it does come with at least one pretty fine tip, which works very well for doing this kind of stuff. So I would recommend that. You can get that. You can get that on Amazon, or Micro Center carries it for like the exact same price if that's a store that you have by your location. Let's see. Trying very hard not to breathe this in. Okay. And, you know, don't be shy with the solder. You know, putting a little more, that's okay. I can see a few places, though, where, like, here, that is going to have to be fixed because that is basically touching the copper tape there. So we'll just have to go back through once we're done soldering and kind of move some stuff around, get it out of the way. So we've done, okay, so we attached 2 rows so far. Let's keep going. Also, you know, since this keyboard is a weird shape, you want to make sure that you check your diagram, you're connecting the correct switches. Once you get to the lower ones, it becomes a little more confusing. Like this, obviously, we're just pretty much going straight across. But when we get down to some of the other ones, let me see if this is still working. When we get to some of the other ones, you see how those are connected there. Here, I'll show you the one for the right side that we're working on right now. Okay, there we go. So you can kind of see where those are supposed to get connected. The top, it's not too bad. The top 4 rows just go essentially straight across. So if you start with the top one, it's pretty apparent what's supposed to get connected. If you start at the bottom, maybe not so much, but you can see the bottom. This is the and then there's this one, which is just 4 switches as a row, and then this one, which is also a row. Oh my god, that was interesting. Okay, so we're gonna lay these on here, keep on going. Yeah, so you know, I think I mentioned in the previous part of this series that, you know, the Dactyl Manuform is it's a really cool project where you know, the developers, the designers, they actually created a script that allows you to generate your own case files. So I don't think I'm smart enough to get that to work. I did try to get that to work. I'm using a Mac most of the time, so I was trying to get it to work on there, but there were several parts of the very involved instructions that just kind of baffled me, so I was not able to get that working. I would like to eventually, because I'd like to try generating some different designs for these cases, but even if you're not quite there, or you're not interested in that or whatever, there are other case designs available. This one, you know, like we said, this one's the 5x6, which just refers to the number of rows and columns. There's also there's a 5x7, and my daily driver board is actually one of those 5x7s. Actually, I'll show you real quick, and then we'll get back to soldering. But the cord is so long. Here we go. Here's just a half of it, but this is the keyboard I use like every day, and of course, like, I think there's an old joke about the the like house builder handyman guy who's like he fixes everyone else's houses and his house looks like shit because he's always working. This one doesn't even have a bottom yet, so I did design like a bottom file for this, which I will put out there because when you look this up, I think this is 5x7 I want to say. It has the case file, but there's no bottom file for it for whatever reason, unlike the other one. So this one, I really like this one. It's just a little bit wider, and this is one where I also threw in a rotary encoder on each side. This side has one, and the left side also has one in the same kind of symmetrical spot. But yeah, I like this design a lot. And these files you can find for free as well. So there's that. So there's also, you know, if you're interested in this like ergo stuff and custom stuff, you would probably be interested in some of the other designs that are available, the other sizes. So that's a design that's larger than this one, but there are quite a few Dactyl Manuform designs out there that are available to download that are quite a bit smaller than this. So there are some with less keys that basically they're kind of acting like more like a 40% layout. It really just depends on how you feel about that. You obviously, you know, it's cool to be able to do everything with fewer keys, but there is a bit of a learning curve there. But it's up to you. I honestly almost thought when I built mine, I really wasn't sure if it was gonna work out. Like I'm not a big learner of new layouts for keyboards, but it actually was not too bad of a learning curve, and I'm okay with my speed on that already. So I don't know, just don't be shy to try new stuff. You might like it. I have not built any of those smaller sizes yet of the Dactyl, but I would like to in the future. There are also some of them that are super strange. I think there's one, I don't remember who did it, but there's one called the Croissant, and that one has, I think it's just like 8 keys, like it's swooping, like high swooping, and it's more like your hand is like pinching it like this, but it's a strange layout, but it's actually designed so that you can do stenography on it, which is super interesting. I have not had the time to get into that yet, but I am very interested in that. If anybody has done that before and you have some experience with it, I would love to hear about that from you. I guess it's supposed to be very, very fast, or you know, once you're good at it, it's fast, and you can type like hundreds of words per minute, which sounds cool. But it is utterly different than your regular like letter-based typing. I think it's all phonetic, so you're creating like the sound combinations of the words instead of trying to spell them out, which is very interesting to me. Yeah, so a lot of those designs, you know, those other Dactyl Manuform case designs that I was talking about. They're available on there's quite a few available on Thingiverse, which is like, to me, I'm a lot more familiar with that universe from doing a lot of 3D printing than I am with GitHub, not being a programmer. So there's quite a few on Thingiverse, but if you want to dig a little bit more, I think there are some that only exist on GitHub, where they're pre-generated case files that are included with whoever that developer was, included with their repo. Let's see. Okay, we're getting there. We're getting there. And I'm kind of just going through on soldering each of these because they are sort of like bunking into each other when I don't do that, and then we have to reset them and go back, and it ends up taking longer. So just doing each one as we go. The first one of these that I built, which was the first keyboard that I built, which was probably a very bad idea, I did this thing where I thought the diodes were supposed to be connected like this, where like the top, the outer end of this one gets connected down here underneath this one, but that basically defeats the entire purpose of the diodes. And actually, that was, I had no idea what I was doing, and I was kind of asking around, and the host of the Board podcast actually ended up helping me and said, "Oh, well, that's your problem right there. You soldered all the diodes, basically sort of backwardsy." He was very nice about it, but I was like, "Oh, okay." And I had to desolder all of them and start over, but I did get that one working, so that was very cool. I think that's probably the best part of this community, is just everybody is pretty fucking nice all the time, which is great. Let's see. Also, I've never had anybody do like a big timing thing where they're like, I'm an important person here, so I don't need to help you out, whatever. Not that anyone needs to help you out, but just anybody I've ever asked for help, and even some people who I haven't, have been super helpful and nice, which is great. This is totally unrelated, but there's a similar thing. I think that's amazing, to be able to curate a space like that, or moderate, or whatever, a space like that online, because most spaces are not like that. The only other one that really comes to mind is and I don't know how much crossover audience there's going to be there, but is the Woodworking Sub on Reddit, which that got me into that too, because the people there are super nice and they just love doing a woodwork. Let's see, we're so almost done putting these on. Look at that. Wowie. I've not poisoned myself yet. 2 more to go, and then we're going to make the actual rows. So these I'm sort of just putting on any old way. When you get down to this little corner here, though, try to aim things away from this corner. Like I don't want to put this like that, because there's not a lot of room once the bottom case goes on here. There's not a lot of clearance between these pins and the bottom of the case. So just watch out for that. So I'm gonna go this way with it, so it's pointing that way. And like we were looking at on that diagram, all 4 of these lower thumb cluster buttons the diodes are basically connected together to form a row there. So all these need to do is touch each other. So I'm going to do this last one. And okay, two solderings, please. A little more. There we go. You just want, if you haven't done a lot of soldering like me, you really just want to make sure you're heating up both surfaces. Whatever you're trying to join, you want to heat up both of those surfaces, because if you're just heating up one, the solder is only really going to bond, it seems like, to that side. So you want to heat up both the leg of the diode and the pin at the same time, and then just flow a little bit of solder on there to connect them, okay? All right, so let's see what's going on here. Okay, so this, yeah, we can probably start back up at the top here again. So what we're doing here, and this is a nice time to have any kind of tweezing device. We must tweeze, unless you have teeny tiny little fingers. Okay. And what we're doing is, I'm gonna try, I don't know if this will work or not. Okay. Oh, that's good. Okay. Is it good? Maybe it's not good. I don't know. Maybe I can show you like this. If I can't do it forwards, I'll definitely be able to do it backwards. Okay, so you see where that little crisscross, is? So that's the first diode in the corner, which is all the way in the upper right of what we were just looking at. That's that first diode's other leg coming out, up from the bottom of this view here, coming out and then crossing over the outer leg of the second diode. So we're just going to solder that together, basically. I doubt I can keep that on it and solder it at the same time. So we'll just go back to our old view here. Okay. Maybe I can get a little closer there. Is that gonna go? Okay, that's good. Just put my hand right in front of the camera and block it out. Sometimes you can get these, you can, kind of set up a few of them and then go ahead and solder it. But for this first one, I'm going to just do that right away. Okay, so we've got those connected like that. And none of this has to be super pretty. This is the inside. I know some people like it to be totally super duper immaculate, which is fine, but it is not going to really make it work any better necessarily. Okay, lift this up and over here. Try to get 2 2 in one go here. Kind of bend them so that they're pushing against each other. If you can kind of see that, like I bent this one so it's pushing against that one, and I bent this one so it's pushing against the next one. So you don't need anything else to hold them when you're soldering them. They're already kind of pushing right up against each other, which is what we want. Okay, that one is good. This one should be easy too. I got shaky coffee hands today. I think that's all right. Okay. The last one I want pretty much sticking straight up so that it's going to be easier to connect our wire that's going to go to the microcontroller. So this one, we'll do like that. And you know, you don't need a ton of solder, but definitely don't be stingy with it. I don't know why it's focusing on stuff that's like far away. I have no idea. So that one looks like it's good. Just gonna get this last one in the corner. Okay, and you know, it's tempting to go through now and trim like this extra piece off and stuff like that, but when I've done that in the past, you can end up cutting off the wrong leg of one of these other ones, so it's best to just leave that for the end, and then you're not going to make any mistakes where you have to put in a new diode or re-solder something you've already done. Let's see. Okay. That one's good. Okay. Let's just do those two first. So it's okay that this is kind of sticking out a little bit beyond where they're connected. We're just going to trim that off once we're finished, okay? So if they're overlapping and the previous one is sticking out a little bit, do not worry about it. This one. And you know, you can kind of feel it, make sure they're actually connected. That's fine. This one, I'm going to move this extra leg out of the way here. Okay. Again, we're kind of just using the springiness of these legs to make them stay together while we do our soldering. So just kind of pushing against each other. And again, you know, anytime we're soldering one of these little joints, we want to make sure we're heating up both sides, like we're heating up this and we're heating up this together at the same time, so that the solder is going to connect well to both of them. This one's going to come up. Okay. There we go. Okay. And okay. Okay. So that's 2 rows done. And you know, these are sticking up kind of high right now, like there's like the diodes are standing kind of straight up. That's fine. You can leave it like that if you want to, but if you're like me and you totally fucked up and didn't put the insulating tape down first, you might want to stop here and do that. that'll be a note. We definitely want to have that taped down before we do this. You know, technically, if you did this and you had these bridges, like this would work right now, but we don't want it to just work. We want it to, you know, be durable. And, you know, if one of these gets pushed down while somebody's messing around in here, we don't want it to ever come in contact with this. So we do want to put that tape down. But that's what we probably should have done at the beginning of this stream. So let's see what we can do to rectify that. This is probably going to be much more difficult now. Ha ha ha. So excited about diodes, you guys. Love diodes. And I get right into it. Okay. Oh boy, this is gonna be fun. All right, let's get some tape. Had somebody ask me what kind of tape it is. This is called Kapton tape. It looks kind of similar to the copper tape, but it is the opposite. I think what this is made out of is called polyimide. I don't know if I'm pronouncing it correctly, but it is I think it's a DuPont product, but the trade name of it or whatever is Kapton. So let's see if we can jam some of this tape underneath these little bridges that we just made. This will probably be the easiest column. Just want to cover that up. And since this is an insulating tape, you know, it doesn't matter if it's, you know, touching both things. It's not gonna hurt anything. I think we're all good on these parts not touching. Sorry, I'm drifting out of the camera there. Just want to make sure that's all good to go. Okay. Need some scissors. Okay. Cover that up. You know, also making sure everything's insulated nicely. It's also gonna protect us from accidentally shorting out any of the wires that are going to the microcontroller later, because there may be an exposed little contact here or there, and we don't want those while they're maybe floating around or whatever. We don't want those to touch anything else by accident. Okay. Let's make sure we got safe distance between the copper and everything else. get all these out of the way. Out of the way. Out of the way. Make sure it's not touching. You know, anything that looks a little close there. You know, now that we've got the solder on those pins, it kind of makes the pin grow a little bit, so it may be a little closer than we want to the tape. I'm gonna look and see. I believe there's an even thinner, you know, width wise. I think there's an even thinner version of this tape, and that might be helpful. This whole thing is actually a lot easier if you're using like regular cherry style switches, because they sit in these switch holes a lot easier, and you don't have to turn them so that both pins are essentially vertical like this. That actually makes it a little harder to deal with. Move this out of the way. Okay. Just get all of this out of the way right now. Okay. Move that. I don't know. This is the step. I don't know. This is sort of adding some extra work to this, but I still am feeling like it is less time consuming than doing the wires, and probably a lot less time consuming if you did things in the right order and learned from my horrible mistakes. Let's see. Almost there. Oops, don't want to eat all the way through that. We need to make sure that stays connected, so I don't want to rip it or push it too far. I also, when I started doing this, I was putting on the keycaps, putting the keycaps on the board and then doing all this stuff, just because I wanted to see what it looked like. But you really don't want to do that. You should just have your switches on with no caps, because otherwise your nice keycaps, unless you put down some nice cloth or something, they're getting all scratched around on your work surface, which is not great. So that is like the last thing we're gonna do. Okay. Okay, all right. So we just have to get this tape going here. Just keep going down the road here and see if I can get this under. There we go. Ooh. Thank you, Tweezers. Great tweezing today. Don't want to trap any of those underneath this tape here. Just watch for the other half of this thing. Gonna be perfecto smootho. Everything in the right order. I'm just keeping on going. Like this one just keeps going and covering everything up. Again, it doesn't hurt anything to cross over into another row or column or whatever, because we're just insulating it. Doesn't matter if it's crossing a couple of different ones. Back this up a little bit. Okay, getting there. Not quite as bad as I thought. Tried to just push all these little leggies out of the way. You don't want to bend these. I'm not real concerned right now, but you don't want to bend these back and forth too much, because they are, you know, they're just lightweight, cheap little things, and they will eventually fall off. So I think we will be fine with what we're doing, but I have, you know, fussing around with the same one for too long. I have broken one or two of them off. Okay, down, down, down. It's, you know, it actually, if we had done it in the right order, it is sticking that copper tape really nicely, actually, which is cool. Move this out of the way. There we go. And I need to get some damn scissors that work. Piece right there. Okay. Just go around and push it down a little bit. Make sure it's not gonna fly off. Yeah, this is not too bad. I thought it would be a lot harder to do this at this stage. Here we go. Move, move, move out of the way. Good. Okay. All right, 3 more. And I am running out of time a little bit for what I can do today, but I'm gonna try to blast through this because I don't want to leave you hanging. Again, really pretty good. That is covering those up really nicely, and it's a lot easier. I've used this tape to cover up like bare wire in here a couple of times as the columns, and it sucks. So this is sticking a lot better because we're sticking it to a flat surface, which makes a lot more sense than a curved little wire. Let's see. Up, up, up. Okay. because they're just two straight lines. Okay, only one more to go. Just moving these other legs out of the way so we don't accidentally tape them down. See, this is why I need to get the chat thing working. I don't know anything about this, so need to get the chat thing working so everyone can yell at me and go, you're doing the wrong thing. You'll never be able to tape that. Sure showed them. Okay, there we go. Do things as backwards as you want. Okay. So I'm just gonna say this is a nice lesson about. I've heard a lot of people say this about how doing keyboards is probably like the most forgiving way to get into electronics, because you can fuck up a lot and still be able to salvage whatever it is you're doing. So yeah, okay, cool. So we're back in business. So we're gonna keep going, soldering these little rows together. Try to get this. It's fine to use your fingers. It's not gonna hurt anything. And I am racing against the clock now, but I think we can do it. This is not the hard part. This part's actually kind of fun. The whole thing is so slow that once you get to a part that's like even a little bit easy and fast, it's very exciting. Okay, here we go. 2 more in this row. Oh yeah, also try not to bonk the side of your case with your iron. Obviously, it's not great for the case, but also it's not great for your soldering iron tip. It can kind of mess it up. If you do, just make sure you try to, clean it off really quickly with your little scratchy little metal sponge. This is another time it's a good idea to kind of refer back to the diagram. Just every once in a while, make sure you're putting the right things together. It's kind of easy to get on a roll and then look back and say, what happened? Like we just did a second ago. See, that was all planned out. We're gonna make it. We're gonna make it. So it was these four become a row, and then these four. So I'm gonna do just a row that is only these. Oops, got a little extra on there. That's okay. No biggie. Connect those. And then these four, this is fun. Basically just going to get all of these to cross each other. Okay, there we go. They're all just, no time for a microscope. Okay, they're all just crossing each other, and we're gonna hit those in the middle of their little intersection. Try not to hurry too much. End up making weird mistakes. Okay, so that is pretty good. Looks a bit slop, but that's okay. We're gonna go through now and trim off these extra ends because we just do not need them. So this is, again, this is a job for your flush cutters for sure. I think some people like to use like a nail clippers or something, but to me the nail clippers are just flush cutters with a shitty handle, kind of. So I definitely prefer these. Also, let's see. Yeah, we want to make sure those little legs are not those can cause problems if they're bridging connections that are not supposed to be. So we're gonna get rid of all of those. And you want to make sure your tape is down pretty well, because if there's exposed adhesive on the tape, once you cut these little nubbin, like little snips of wire off, you can shake them all out of the case, but if there's exposed adhesive, they're gonna stick like underneath, and sometimes in spots where you're not going to see, and then that can cause, you know, you got this little piece of wire that's connecting two things that aren't supposed to be, and then you're gonna have to figure out why your keyboard is not working. So I'm just gonna keep on cutting here. And I'm trying to get as close to the pin on the switch as possible. I don't want really any of that sticking out at all, because any of it that's sticking out could become a problem. So I'm trying to get rid of it as much as we can. Cut it all the way back. Just be careful not to cut your pin off of your switch, because that would be bad. Then you gotta put a whole new switch in there, probably, which is kind of the opposite of what we want to do. Just if you see any tape sticking up, just push it down so it's not gonna trap those little thingies. Okay, you can also, I kind of use these, you know, to cut and then also pick up the piece and take it out. Also, I think I'd love to say this was a genius move, but these have become magnetized a bit, which I've found actually really useful, especially just for picking up these teeny tiny little pieces of things. Yeah, nice. Okay, so those top 2 rows are done. Get this one pulled up the tape a little bit. If you have teeny tiny little hands in this hobby, you're going to be able to do everything so much faster. You can just climb right down in there, set up your little chair, sit next to each one, and chop them off. Oopsie. Yeah, if you can remove the pieces as you go, that's ideal, because then you're not gonna end up with like, oops, I didn't even know there was a little piece floating around and it's messing me up. Okay, let's keep going. Oy, that sounded, I thought I cut the pin off the switch. Nope. Okay, safety first. Come here, you. There we go. I guess you could cut these and then go back through with, you know, your tweezers, however you like to tweeze. I'm not gonna tell you how to tweeze. This is America. Tweeze whoever you want. Okay. Getting so close. That one's kind of hiding. That I'll have to watch too, that those don't get pushed together at all. Danger zone. Okay, this, boy, that one's confusing. Okay, that's it. Yeah, see, that one got stuck to the bottom of the tape. Okay, got that. 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 Oh my God, we're almost out of time. Intensity. Done. And we want to leave one for this here. You can see like all these other ones, I'm leaving a leg just sticking out, you know, so that we have something to attach our wires to actually go to the microcontroller. This one right here, please focus. Okay, this one right here, you just want to leave one of these sticking out so that you have something to connect to. I'm gonna leave that one. It does not matter which one you pick. Okay, so now there's just one sticking out there. Okay, I think we are doing good. Made a good keyboard. Okay, pretty darn good. Okay, so that is exactly how much time I've got today. So next time we will do some more. We're gonna probably, the first thing we'll do next time is start adding the wires that are going to go to our microcontroller. And I'm gonna show you two different ways to do it. One of them will be with just soldering stuff straight to the microcontroller, and then the other way, which is sort of preferred, is going to be to add what's called little DuPont connectors to the ends of those wires, so that it's easier to put them on and take them off, troubleshoot, and do more modding later after the board is finished. Okay, so thanks for watching. This is Kevin, and I'll be looking for you in the comments, and I'll see you for the next build stream, which will either be later this week or early next week. Thanks again.